So after doing the whole first video in orange, I decided I didn't like it, so we're back to red. We want to know the values of a, h, and k. Okay? Well, our format is y equals a times the square root of x minus h plus k. So we don't have a number in front of this, so our a value is going to be 1. Square root of x minus what? How would we get to plus 4? Minus a negative 4. So our h is actually negative 4 in this function here. And then k, how would we get to plus whatever k is? That would be plus negative 5. So k is negative 5. So you see k following the sign in here, and h being the opposite sign. Alright, number 10 is a little more tricky, because we got some stuff going on underneath the radical here. So let's see what we could do to simplify our lives a little bit under the radical. So 4 and 20, is there a greatest common factor that we could take out of those? Because if there is, we want to do it. We've got 4 times x, and then what times 4 gets us negative 20? That would be a negative 5. So once you've got that, you can just ask yourself, can I take that 4 out of the square root? Because what we can do is, since we're multiplying two factors under the square root, we could split up those square roots. So we got the square root of 4. What's the square root of 4? It's 2. 2 times 2 would get us 4. So what we've really got is y is equal to 4 times the square root of x minus 5 minus 1. And now our a, h, and k values are a little more clear, I think. So a is equal to 4, h is equal to a positive 5, and k is equal to negative 1. Number 11, a transformation of the graph square root of x. Y equals the square root of x is vertically stretched by a factor of 9, reflected across the x-axis, and then shifted left 3 units. So that vertical stretch of 9, well, this isn't a vertical stretch of 9, that would be a 9 out here. This is a vertical stretch of 3. This is a stretch of the square root of 9, so the square root of 9 is 3, so it wouldn't be any of those. It's going to have to be d, but let's check it, because if you did 11.1, you remember that one time the answer wasn't even on there. So let's look. Okay, we got the stretch by the factor of 9, reflection over the x-axis, that's what that negative sign does, and then left 3, so that plus 3 is telling us to go left 3. So we've got all those pieces right there. Numero 12. So we've got the square root of x is being transformed again, vertical stretch by a factor of 8. Okay, so this is not a stretch by a factor of 8. This actually is, because the square root of 64 out here would be 8. Square root of 64 here would come out as 8. So we eliminated b, and it's reflected over the y-axis. Okay, so which one, where does the negative sign have to be for it to be a stretch or a reflection over the y-axis? That negative sign has to be inside the square root sign. So it's actually going to be a. Because a could be rewritten as, well, what's the square root of 64? It's 8 times the square root of negative x. And again, I'm going to beat this to death. You don't have to be just the most fluid person ever with square root functions to get some of these things right. Let's, so the square root of negative 64x, I graphed that in my simplified version. And you can see it's very much stretched vertically. That's what the stretch does. It makes it get taller faster. Let's look at the table. So my when I simplified it in the correct way. Okay? And so if you were to write it if you were to write the function f of x from the problem statement, you would probably write it like this. You probably wouldn't write it with the square root of 64 somewhere. And so then you'd look at b and d, and you're like, well, neither one of those is what I wrote. And so you'd start looking at a and c. And if you couldn't figure out to take the square root of 64 out of there, then graph them both and see which function is equal to your function. And then that's going to be your answer. So you can see in here, you got the reflection about the y-axis that they asked for, and a stretch by a factor of 8. So you're good to go. On to number 13. And then we get into some modeling. Modeling's my fave. Zoom out a little bit. I'm gonna get my lamp back on. Get my life together. Okay. Write an equation that best describes a square root function that's reflected about the x-axis and has a vertex of -3, 5. Alright, so x-axis, where's that negative sign going to be? If we're doing a reflection, that's going to be a negative sign outside the square root, right? Okay. Well, let's graph this function, see what it should look like. -3, 1, 2, 3, 4, 5. So it should start up here. Oh, JK. Wait, it's reflected across the, yeah, it's reflected across the x-axis. Okay, so since it's reflected across the x-axis, square root of x looks like this. Negative the square root of x looks like this one. So not this line. We're looking for a line that looks like this. Since it doesn't have a stretch or a compression, we're going to follow that pattern we talked about in the last video. Down 1 over 1. Down 1 over 1, 2, 3. Down 1 over 5. And so it'll look something like that. Okay. So I drew it. Now let's write it, and then we'll graph it and see if it looks like that. Reflection across the x-axis, that means our a value is now just -1. So negative square root of x. If we shifted to the left 3, then under the radical we're going to have an x plus 3. And then up 5, so plus 5. So there's my answer, as long as it looks like my graph on the paper. Negative square root of x plus 3. After I type that 3, I hit the over arrow to end the square root line. And I would say that it looks suspiciously like my graph here. We even go to the points. -3, 5 should be our first point, and it is. Then -2, 4. Then we went down 1 over 3. So down 1 over 1, 2, 3. So we've got the right line in there. So there's our answer. Alright, for the next ones, you're modeling scenarios with square root functions, or looking at models that can be modeled with square root functions to answer questions. Okay, so we've got a square that's represented by area is equal to s squared, so s must be the length of a side. And then it says you cut it into a diagonal, you have 2 triangles, and the area of one of those triangles is 1/2 of s squared. Makes sense? Suppose the area is 128. So area is 128 centimeters squared. What was the length of one of the original sides of the square? So it looks to me like we just need to plug this in to our equation. So how do we solve for that? We're going to need to multiply this both sides by 2. 128 times 2 is 256 is equal to s squared. Okay, and then how do we undo a squared term? We do the inverse, which is to take the square root. And so s is equal to the square root of 256. If you haven't been doing square roots of 256 recently, you can type that in. If you've memorized all the way up to 16, you know that s is going to be equal to 16 centimeters. Number 15. Suppose the winner of, just kidding, we'll do 15 on a different video. Come back for video number 3, we'll do 15 through 19, and then we'll have another video for the problems.